This is chapter 2 of microprocessor architecture and the pin diagram. So today we will see the architecture and the pin diagram of the microprocessor. Now, what is the feature of 8085 as we have into the 8085 is developed by the Intel programming, right? It is a it is a second generation of the processor. First, it is a 4-bit of the processor has discovered, and then it is a 8-bit processor. It is developed by the Intel programming. As we say, the Intel microprocessor we need to purchase for our computer, so it is developed by the Intel. 8-bit microprocessor, it can accept the 8-bit data simultaneously. It is also called as the 8-bit microprocessor. Earlier it was a 4-bit microprocessor, then 8-bit, then 16-bit, then 32-bit, then 64-bit. Nowadays it is a 128-bit microprocessor to 56-bit microprocessor. So this is the development in microprocessor generations, right? Operations on plus 5 volt and uh, plus 5 volt DC supply. It required only the plus 5 volt DC supply. The design using the NMOS systems technology, NMOS technology, right? The MOS we have seen into the logic family, NMOS, PMOS, right? So it is used the NMOS technology. 6,200 transistor on a single chip. So what is the evaluations of that? Earlier the transistor used to so big. Nowadays it is miniaturizing the size. So 600 and 200 transistor into a single chip is a microprocessor. It provides on chip clock generator, and hence it does not require the external clock generation, right? It is a on chip, so inside the chip there is a clock generation. Operation on 3 megahertz clock frequency. It has a 3 megahertz clock frequency, right? 8-bit multiplex address and data bus. While we are seeing the bus diagram or the pin architecture or the pin that we can see, it is multiplex the address and data bus by ALU arithmetic ALE address latch enable. It is demultiplex when it will be the address bus and when it will be the data bus. So it is miniaturize the signals of the pin, microprocessor pin, which reduce the number of pins. It is due to this multiplex, it reduce the number of pin. It is a 40 pin ICs. We will see the pin diagram. It is 16 address lines, and hence it can store address is 2 to the power 60, 64 kilobyte of memory maximum we can interface to the microprocessor 8085, right? It is a 16 address line. Hence, it can be a addresses 2 to the power 16, means approximately 64 kilobytes of memory we can interface it. It generates the 8-bit input output addresses, hence it can access 2 to the power 8. 256 input output ports are there, right? 5 hardware interrupt, that is a trap, RST 6.5, RST 5.5, RST 4.5, INTR. This is the hardware interrupt. Why it is used the hardware interrupt? Because it is processor is performing a task, but in case of any emergency and the hardware interrupt wants to interrupt the working program, so it is a interrupted things there. Hardware interrupted. Suppose you have designed your system for the just to monitor the smoke, so your process is going on just monitoring, but very amount of smoke is comes, so you need to do the alarm. So your currently executed program is interrupted, and it runs the buzzer program. So that is called the hardware interrupts, right? And it provides the DMA, means direct memory access. As we have seen, the microprocessor input output devices and memory. So it is not necessary always your from memory data it is goes to the microprocessor then input output devices. It can be directly communicate with the input output devices and the memory. That is called as the direct memory access without involving the microprocessor. So these are the features as the 8085. Now this is the architecture block diagram of microprocessor. Now we'll go for the resistor, right? So in microprocessor, there are the 6 resistor and one more accumulator, right? So this is also the register. The register naming as accumulator, it is denoted by A. It is a 8-bit register. It performs all the arithmetic and logical operations, right? It is very, very important register into the microprocessor. So this is a 8-bit register. It can be combined with program status word, means 8-bit accumulator plus the flag register. Flag gives the status. We'll see later on what is a flag. So it forms the 16-bit register, right? So accumulator is a 8-bit register. Whatever the processor is performing a operation into the arithmetic and logic unit, for one data has to be in a accumulator, so it performs with the accumulator. That's why this accumulator is connected to the arithmetic and logical unit, and it gives the flag register. This is also the 8-bit register. Is it clear? Second register has a B, C, D, E, H, L. All register are 8-bit register individually using. But if they can pair, it can be used as a 16-bit register. But they can be paired by using only BC, only D, only HL. No vice versa. That is CD, DH, DL. No. It will use only BC as a pair, DE as a pair, HL as a pair. It is called as the 16-bit register. Is it clear? So there are 7 8-bit register individually: A, B, C, D, E, H, L, right? And there are pair is there: BC pair, DE pair and HL pair, right? So this is BC, DE, HL pair are the 16-bit register, right? 8 plus 8, it is a 16-bit. Then the register, this is called as the register array, right? Then the stack pointer, it is called as the SP. There is a stack. Stack means what? It is a first in, first out. It is a first in, last out. So any water, if it is a water jug, we stored the water, so it is a water stack of water, right? So we'll take last bucket and then we'll remove that last bucket. Any container of grains, we'll put the grain inside. So those are the upper grain, we will take it first, right? So it is called as the first in, last out, or last in, first out, right? So it is a stack. SP, it is called as the stack pointer. It is pointing a stack memory, right? Program counter, when you are writing a program into the memory, this PC register, this is a 16-bit register, it is pointing to the next instruction which has to be executed or which has to be a fetch by a microprocessor. So this is a program counter, a register. And this is increment and decrement address latch. This is a 16-bit register. Now this address latch has a 8-bit address buffer. Again 8-bit address buffer, but this 8-bit and this 8-bit data buffer is demultiplexed with each other. It is a multiplex address of a higher bit, lower bit, and the data D0 to D7, it is multiplex. When it is using this data line or when it is using this address line, it will define the address latch pin, right? This ALE is, it will define address latch pin. So it is naming as AD7 to AD0. So if it is demultiplex, what is the signal? It is A7 to A0. If it is demultiplex, the signal is D0 to D7. Otherwise it is combining AD7 to AD0, and then AD7 के बाद जो A8 to A15, this is your separate address line. So total address line is A15 to A0 and your data line is D7 to D0, right? This is your data line. It is 8-bit data bus is going on. Clear? Now you know that the microprocessor are doing 3 things. It is a fetching instruction, it is decode the instruction, and it performs the task. So now this address, it fetch the instruction, it gives to the instruction register, right? It instruction register, it decodes the instruction register what to do, and as they decode the instruction register, it gives the time and control, right? And this time and control will perform the task with the accumulator and temporary register. It performing, it gives the status flag, and again it's transfer the data, whether it is memory, whether it is output, whether it is input. That's why these data line are bidirectional and address lines are unidirectional. It's only sends the address, and from that address it fetch the data. It only sends the address, and from that into that address it stores the data. So the always data lines are demultiplex, is taking a data from the memory, it giving the data into the memory, but address is only from microprocessor to the memory. So it is a unidirectional, it is out from the microprocessor, right? So that is a basic concept, right? Now the rest, this is your interrupt control unit. It has a interrupt intr, and this is the acknowledgement. This is RST5, RST 6.5, RST 7.5, and trap interrupt. All these are the interrupt. Serial input output SID, serial in data, serial out data. We know that this microprocessor is in a parallel mode, means simultaneously 8-bit data you can transfer, you can from to from my memory to microprocessor, or input output devices. But there is a concept of serial, means one bit it can become. So this is the serial input output control, that is a serial in data, serial out data. So what are the units are there into the microprocessor? Interrupt control, serial input output and the time and control. Time and control, as this is your 40 pins, so plus minus ground and plus minus VCC. X1 and X2, it is a clock signals. So clock generation out, whatever the clock generation, the same frequency with the same time clock pulse, your input and output devices also run, because while you are transferring data, so that devices should be ready with the same clock pulse. So it is a clock will generate, and the same clock pulse will give it to the your peripheral devices, that is a input and output devices, right? Ready pin, ready microprocessor, whether the pins are ready or not, out your control pin, your input output devices pin to take the data, to give the data, so that the ready signals are there. Read write, it is a performing your microprocessor, whether it is a read operation or write operation, both are the output pins from the microprocessor. Now ALE pin, address latch enable, S0 S1, it gives the status of what it is doing exactly. IOM means your operation is with memory or input output devices. Your operation means microprocessor operations is with input output devices or the memory. DMA, we have seen that direct memory access, that has a 2-pin hold and hold acknowledgement. Hold means what? There are single data and address line, and DMA is performing operations transferring the memory data into the input output without involving the microprocessor. So now the DMA has to take the control of data and address lines. So the DMA will send the signals to the microprocessor, that is hold. I will use your the data and address line, you should hold there. So DMA will take the charge of the address and data line and transfer the data, and after that it gives the acknowledgement to the microprocessor, yes, I am performing the microprocessor operations, right? Reset in, when it is, when you want to reset any you, if you want to reset your a mobile phone, you will just reset and everything will be a reset. So reset in, when your processor is reset, processor has to reset the dependent devices, so the reset out signal also there, right? So these are the basic pins of the microprocessor. This is a 40 pins. This is the basic architecture block diagram of your 8085, right? What is there? This is a address array, instruction register and decoder. This is a flag, This is temporary register. Whatever data you are taking into this temporary register is used for inside the microprocessor, not for the user, right? While user writing a instruction, where user will use this register B, C, D, E, H, L, stack pointer, not even the program counter, then accumulator. But this temporary register is for the microprocessor performance. Suppose you want to add the data that we have seen one instruction add B. So that means what? Accumulator data is adding with the B register data and the result is into the B. So what it is performed? The accumulator has the data, then B register will send our the data into the temporary register. It will come into the arithmetic and logic. It will perform, right? According to that performance, what are the flag status, it gives to the flag register, and again the result will stored into the accumulator. So that wise accumulator is also the bidirectional data. The result will stored into this accumulator, right? So this is the performance of. So this is the basic architecture diagram of our microprocessor 8085, right? Now, the 8085 consists of block diagram, register array as we have seen, arithmetic and logic group also, instruction decoder, machine language, encoder, timing and control circuit, interrupt control group and serial group. These are the general purpose register. As I have explained, this is general purpose register. B, C, D, E, H, L are the 8-bit register, can be used single, can also be used as a 16-bit register pair B, C, D, E and H, L. Used to store the immediate data and result. H, L can be used as a data pointer also to hold the memory address, as we will see. Special purpose register, accumulator and the flag register. Accumulator is user accessible. All the ALU operations are performed with the ref container of accumulator. The result of the operation is stored into the A and 8-bit data during the input-output transfer, right? Then the B, instruction register, use not accessible. It is not user accessible. When instruction is memory, it is loaded to the IR and then transferred to the decoder for decoding. It is a programmable and cannot be accessed through any instruction, right? It cannot be accessed through any instruction. B3, it is a flag register. F, usually accessible. 8-bit register, it indicates the status of ALU operations, right? All the flags in all the ALU includes the 5 flip-flops and which are set or reset after an operation according to the data conditions of the result accumulator. So this is a standard flag register. S is for first, it will show the sign of your bit. Z means it is a 0 flag, sign flag, 0 flag. If your result is non-zero, 0 flag will be a 0, right? If your result is 0, your 0 flag will set to 0. Auxiliary flag means it shows the 4-bit of operations. Parity means if your parity number of ones is in a odd or even, it shows the parity flag. And if it is a carry, 8-bit operation has a carry, so it will just give the status of the carry flag. So this is a flag register. Generally the question is asked on the flag register. Write a format of the flag register, explain the flags with the examples and all. So this kind of questions is arise on the flag registers. Now the carry flag. Carry is set when the arithmetic operation generated the carry out, otherwise it is a reset to 0, right? Carry arithmetic operations, any arithmetic addition or subtraction, if the 8th bit is there, 9th bit is there, it will set to 1, otherwise it is a reset. Parity, if it is a 1, in the ALU result operation has even number of ones, so even number of ones, suppose your data is 0 0 1 1 and 1 1 0, so there is a 4 1, right? So your data is, the result in the accumulator is has a 4 1, so your result, parity of that result is even, so it will shows that 1. If it is a 0, if the number of ones is odd, अगर रिजल्ट में नंबर ऑफ वंस 3 है तो योर पैरिटी विल सेट एज अ 0, राइट. Auxiliary flag to the similar a auxiliary flag is 1 if the carry of D3 to D4, right. So LSB bit of data means D0 to D3 operations perform. If that D3 to D4 bit is generated, any carry auxiliary flag will 0, auxiliary flag will set to 1. If it is not generated, auxiliary flag will 0. Zero flag if the result is A is 0 0, means your operation result has 0 0, your zero flag will set 1, otherwise it is 0 always. Sign flag, it is a D7 bit of the A is 1, it's indicate the negative number, so the D0 bit is 0, its number indicates the your result is positive, as we have seen into the this code generations, right. So the same, it is D7 bit will indicate whether your number is positive or the negative. So we do the 2's complement if it is a negative number and all this, so it gives the representations in a microprocessor, right. So now 8085, it is a temporary resistor that is called W and Z, that there is a temporary resistor. So data is initially used by the microprocessor, user not accessible. This is W and Z register are 8-bit capacity used to hold the temporary address during the executions of some instruction. This is the temporary register. Temporary data register, this is a 8-bit capacity used to hold the temporary data during the ALU operations. So these are there. This is two instructions. These two registers are very important. These are the special purpose registers. So pointer registers or the special purpose register, it is called as the stack pointer and program counter. So now this is a stack pointer, right? We can say that the SP. So stack pointer is a 16-bit register which hold the address of the data presentation at the top of the stack memory, right. It is a top of the stack memory. Now in this address you need to put the data, or from this address you can access the data. So top register data, it is received the area of memory in a RAM to store and retrieve the temporary information, right. Also hold the content of program counter which subroutings are used. सपोज देयर इज अ सबरूटिंग प्रोग्राम्स, ये प्रोग्राम के बाद ये प्रोग्राम में जाना है, तो ये प्रोग्राम का नेक्स्ट कंटेंट इट विल स्टोर्ड इनटू द स्टैक पॉइंटर. सो द प्रोग्राम काउंटर आफ्टर कंप्लीशन ऑफ दिस program counter will come back to the main program from where it has to continue, but that address is stored into the stack pointer, right. So that is used for the program counter. When there is a subrouting calls or an interrupt, pushing the return address on the jump or retrieve it after operations is completed and come back to its original locations, right. And program counter, this is the second special purpose register. It is a 16-bit address for the execution of program containing the address of the next instructions to execute. For the fetching the instruction, it is automatically incremented by 1. We don't have to do it, it is automatically incremented by 1 and it is pointing to the next instructions to be fetched by the microprocessor. Not much use in a program, but as used in an indicator of user only. It is not used much more, but it is used as an indicator. Increment and decrement address latch, right. There is a one register that is increment and decrement. It is a 16-bit register, right, used to increment or decrement the program counter and stack pointer. Only this register will do it to increment and decrement of program counter, that is a PC, and stack pointer, that is a SP, right. Address buffer, 8-bit bidirectional buffer, used to drive high order address bus age 8 to A15, right. When it is used under such a reset, hold half its, this buffer is used to tri-state high order address, right. This is A0 to A. The data and address buffer AD0 to AD7. So this 8-bit bidirectional buffer used to drive low address A0 to A7 and data D0 to D7. Use certain condition as a result, hold the half etc. This buffer is used right state to load the address bus, right? These are the address bus. ALU and logic group, it consists of ALU, accumulator and temporary resistor and flag resistor. ALU. ALU perform arithmetic and logic operation, stored result and arithmetic and logic operation into the accumulator. Accumulator is a general purpose resistor, stored one of the operand before any arithmetic and logical operation. एक operand एक data accumulator में होना चाहिए before performing the operations, right? It again stored back into the result. Result also again stored back into the accumulator. Suppose 5 plus 3 करना है तो 5 has to be accumulator. So 5 plus 3, your result is 8. Again that 8 will be stored into the accumulator. So your result is into the accumulator. So it is a 8-bit data during the IO transformation, right? So this is 8-bit data. Temporary register. So 8-bit register during the arithmetic and logical operation, one operand is available in A and other operand means other data is also available into the temporary register. For example, ADD-B. So it contain B is transferred into the temporary register before actually addition, right? The flag register. 5 flag is contained to the ALU. After ALU operation, it performs the status of the result will be stored into the 5 flag. So it is a flag register means it gives the status of the result what arithmetic and logical unit has performed, right? Now the third, increment and decoder, machine cycle and timing diagram. Instructions decoder, machine cycle and timing diagram. Instruction decoder and machine cycle encoder, right? IR, decoder and operand stored into the instruction register. Establish the sequence of event to flow, right? Instruction decoder, it will establish the sequence to event to flow. Encode it and transfer to the timing and clock unit, control unit to perform the execution and instruction. So that is a task of instruction and decoder register. Time and control circuits work as a brain of the CPU. For proper sequence and synchronization of operation of microprocessor, this unit generate all the timing control signal necessary for the communication between the microprocessor and peripheral. So that controls has to be there. Interrupt group register, that is the upper side there is a interrupt group register. Interrupts occur from the external disturbance, right? After servicing the interrupt, 8085 resume to the normal work sequence. Transfer the control to the specific routine. There are 5 interrupts, generally ask this into the exam. How many interrupts are there into the microprocessor? What are their priorities? Who is high maskable interrupts? Who is non-maskable interrupt? So non-maskable means cannot be avoided. So trap, RST 7.5, RST 6.5, RST 5.5 and interrupt. So trap is not a non-maskable interrupt. अगर कहीं कुछ चल रहा है और आग लगे और तुम उसी रूम में रहोगे, तुम्हें तो बाहर निकलना ही पड़ेगा because you cannot avoid the fire. So that is a non-maskable interrupt. But if any peon is come, any person is come ringing the bell, you can avoid, let him ring and let him go. So this is a depend upon the priority you are giving to whom, whether that interrupt is accept or not. But some of the interrupt it has to be accepted, just like I have given you the fire example. If there is a fire, whatever the work you are doing on this fire, you need to accept that interrupt. So this is a trap interrupt. The serial input output control. So data is transferring on D0 to D line is in a parallel data. right? But under some condition it is used the serial data transformation. Serial data is entered the SID serial pin, and it is a input receiver, and serial data output on the SOD pin, it is a output receiver. So this is the pin diagram. There is a 40 pin IC. The number 40 is VCC, number 20 is ground, right? Number 20. Rest all are X1, X2, reset out, SOD, SID. SOD is output pin, reset out is output pin, SID is input pin. Trap RST 7.5, RST 5.5, 6.5, RST 5.5. INTR, INTR A acknowledgement pin. AD0, AD1, AD2, AD3, AD4, AD5, AD6, AD7, and ground, right? A8, A8, A9, A10, A11, A12, A13, A14, A15 address pin. S0, S1, it is a combined pin. Read write VPP. This is input output or memory. Ready, reset,